exponential random variables.
Mm-hmm.
First question, what's a random variable? Do you want to have a go, Ryan?
I don't know if I know the definition of a random variable.
Oh, I can't even spell variable.
Is it like when you have the table and you sub it in? Or is that discrete?
That sounds more like something discrete. We're going to use continuous ones
Yeah.
for this. So a variable represents something you don't know. Right?
Mm-hmm.
That's what they're for. Normally a variable would represent a number of some kind, although exactly what constitutes a number? I mean, is a complex number a number? I mean, is a matrix a number? Is a vector a number? A variable represents something that we don't know. So a random variable represents the outcome of a random process. So I flip a coin and I have a random variable that tells me whether it's going to be heads or tails. Or for the ones we're going to be looking at, it's going to be a random variable that represents the time interval before the next phone call comes in, or something like that. In fact, they almost always represent time for these ones, but not always. So it represents the outcome. Now, you can say a random process, or if you want the fancy word, it's stochastic. I guess if I say stochastic, you're all going to say define stochastic, right?
Yeah.
So maybe I will just say random. A random process. Something happens for which there's a predictable kind of way of work I don't know how to say that. It's not random in the sense that it's completely unpredictable. It's random in the sense that it follows some probability distribution. I can describe the probability of it happening. An exponential random variable represents a time or a distance before the next event happens. Variable represents the time or distance. There are some other alternatives. Before the next event happens. For example, you're serving customers at McDonald's. How long between one person arriving and the next customer coming in? Things like that. We will follow a convention that Year 12s have already seen, but you don't know yet. So the random variable might be an X, or a T is always capital. So this is the variable. It has a distribution. And a specific outcome will be a lowercase. So specific value is lowercase, but the variable is capital. So you'll see me following this convention. It's to help you understand what I'm writing. There are two kinds of parameters. There's things like a mean time between calls, or I might describe it instead as the rate at which calls happen. Calls per unit time. So we're going to use the mean, for example, time between events. We're going to use mu as our mu. But the rate, events per second or whatever, is going to be lambda. What's the relationship between the time between events and the events per unit time? What's the relationship between mu and lambda?
Wait, say that again.
If there's, for example, 4 calls per second, what's the mean time between calls?
0.5 of a second. 0.25.
0.25, a quarter,
Yeah.
right? If there's 3 hours between something happening, then the rate is approximately a third of an event per hour, 1 over. So lambda is always 1 over mu. Or if you prefer, mu is 1 over lambda. So if you've got one of those parameters, you can work out the other one. But read the question carefully, because the question might give you the mean time between, or the question might give you the rate. You have to know which one.
Right.
You have to know whether you're given this or given that, because you've worked the other one out. Now, for an exponentially distributed random variable, the probability, well, there's two ways people call this. Probability, do you want me to call it distribution function or density function?
What's it actually called?
I'll call it the proper name, density. You can call this probability distribution function, doesn't matter. Probability density function, often called PDF, usually lowercase, is the probability of something happening, actually because it's usually time, I might use t, is, I can't draw a brace today, lambda e to the negative lambda t, if t is positive, and 0 if t is negative. What is a probability density function? I can't even say it today. You want to try and describe that, Ryan?
No idea.
Haven't seen them before?
I haven't seen that.
You have actually seen them before.
No, the lambda.
What's this, Ryan?
A line? Or two? A graph?
This.
Oh,
It's a normal
yeah, distribution.
PDF, yes.
Yeah.
Or normal distribution has something, many people call this a distribution function.
Okay.
Right, that's a PDF. What this tells us is, given some score, what's the probability of getting that score? That's what the PDF tells us. So the exponential one doesn't look like that. What does e to the minus t look like?
It's flipped.
What does e to the minus look like? But we're ignoring the negative part of that. So the PDF for an exponential random variable just looks like this. 0, and then goes getting closer and closer and closer to 0. So the probability of being negative is 0. If it's the time between the last event and the next one, it can never be negative. It's most likely to be pretty quickly after, but there's a small number of times where it happens a long time after. Now these lambdas here change this a little bit. Basically they just stretch it a little bit for a specific reason. If the probability of any given point is the value on this curve, then what is the total area underneath that curve?
100.
100 what?
I don't know, percent.
100%, which is
1.
1. So the area under this curve has to always be 1 for it to be a valid PDF. So these parameters here make it so that this area under here, going all the way out to infinity, is 1. I'm not going to attempt to prove that, but you can. Or do you want me to prove that?
If it goes to infinity, can it be 1 then?
Yes.
But how? Because it's going infinitely.
You have done APs and GPs, right?
I don't know about that.
They don't do it anymore. It's not in the new syllabus. Arithmetic sequences, geometric sequences. Yeah. So for a geometric sequence to converge, have you heard that kind of language?
Not converge.
Okay. It really uses maths that's first year uni course. It is. Let me show you. I want to know what the area under this curve is. What operation am I going to be using? Integration, right? So let's have a look at this. I want the area under the curve. Now, the probability is 0 on the left-hand side, so I'm going to ignore the left-hand side. I'm only going to look at the right-hand side. So I'm looking from 0 to infinity. I can't even draw an infinity today. Of lambda e to the negative lambda t dt. Well, what happens if I integrate this? One of my year 11s want to have a go?
No, I'm good.
Sorry?
I'm good.
No? Ben?
Yeah, I'm good.
Constant lambda. This function doesn't change, but I have to divide by the negative lambda. You okay with that? I'm going to rub out these lambdas to make it a bit neater. That's what I've got left. Which means I've got negative e to the negative infinity, think about what that means, minus negative e to the 0. This is 1 over e to the infinity, right? But if this is infinite, I'm basically 0. So this is 0 plus 1.
So it's an approximation if it's basically 0, it's not actually 0.
Well, if I actually get to infinity, which is my limit, it will be 0.
But you can't get to infinity, right?
But this whole expression is a limit. So I'm actually interested in what happens in that limit.
But isn't that just a fundamental problem then? Like, it inherently doesn't really make sense.
It's so small that you can't put a number between it and 0. So it's 0.
Okay.
Because you're dividing by an infinitely big number. I'm absolutely not going to put the limits in and show you why that works. No.
Yeah.
But you could if you really wanted to. So the area under this curve is 1, which means it's a valid function for us to use as a PDF. But be careful, this is continuous. The probability that my random variable equals some particular number is 0. It's never going to be exactly that because it's a continuous distribution. But I can ask for, and that's actually exactly the same as, it doesn't matter whether you put less than or equal to, or greater than or equal to, because the probability of it being an exact specific value is 0, because you're asking for what's the area under a line. Well, that doesn't make sense. It's 0. You need some width in order to get a probability out, get the area underneath. So it's kind of a technicality, but it means it doesn't matter which of these you use. You'll get the same value.
But what if you wanted to get like that? Like
It's 0. You have an infinite range of possible values. Infinite. So again, the probability that it's any particular individual single real value is 0.
oh, so it's negative
Because it's 1 divided by infinity.
Yeah.
So it's 0. It's just a way. This only works with continuous random variables. It's the way we talk about continuous random variables. If it was discrete, no, we would have specific values with specific probabilities. But they're continuous. So, let me show you what we can do with this. What am I going to ask you? Oh, I should point out, so sometimes I'm going to be looking for, maybe I'll give you an example, that would be the easiest thing to do. So, let x be a random variable that represents the time before the next bus arrives. At a bus stop. So it's a random variable. It represents the time interval before the next thing happens. I might go comma, where x is exponentially distributed. You'll see language like this, exponentially distributed, or you might see language that says it's an exponential random variable, or words like that.
Does that just mean it fits into that?
That means this is going to be what my probability density function looks like, yes. Okay? And they might tell you, on average, a bus arrives every 8 minutes. Every 8 minutes. Oh, I can't spell minutes. Minutes. Determine mu, lambda, and the PDF. You'll always have to do that. The first question, on average arrives every 8 minutes. Is that mu or lambda?
Mu.
Mu is 8, correct. So mu is 8. So lambda is 1 over 8. And you can write 1 over 8, or you can write 0.125, I don't care. Doesn't matter. And we can write our PDF. The probability, let's use x, because we've got capital X, is 1/8 e to the negative, I can't even write it, 1/8 t, if t is at least 0, and 0 if t is less than 0. That was a little bit messy. Negative 1/8. Again, you can put 0.125 here instead if you prefer. Doesn't matter. What's the probability that the next bus will arrive within the next 3 minutes? Calculate the probability that the next bus will arrive within the next 3 So I want the probability that the next value I get out, now here you can either use a capital or a small. The next value I get, I use a small because it's the next value, but some people put a capital here. Probably the next one I get out is less than 3. That's what I'm looking for. Some people just put a P rather than a PR. Doesn't matter. Okay, well that's an area under the curve. Maybe I'll illustrate it for you. My function goes like this, and I want 3. I want this probability. I want this part of that curve. I want the area under here. That's a probability. So I want the integral from 0 to 3 of 1/8 e to the negative 1/8 t dt.
Can't we just use our calculators? Like for the...
It doesn't have this built in.
Really?
Really. Oh, sorry. Depends what you're asking. It doesn't have, well, it probably doesn't have exponential random variables built in as a distribution. But yes, you can use a calculator to do the numerical integral if you want it.
Like if I use the PDF function in my calculator, it won't let me just get to the answer straight.
No, because the PDF function will be based on normal.
Okay.
And it probably also has binomial.
Okay.
But it likely doesn't have exponential. The TIs certainly don't. You could check whether yours does. But the reason is it's actually very simple.
Yeah.
It's actually not hard to do.
Yeah.
The normal is much, much harder to integrate. So we're going to go, if you have your calculator, you can do that, but what if it's tech free? Well, all we're going to do is go, and if I integrate this, I'm going to be dividing my negative 1/8, so it's just going to be negative e to the negative 1/8 t from 0 to 3. These codes are warm, but they're also a bit noisy. Okay, negative e to the negative 3/8 plus e to the 0, which is 1 minus e to the negative 3 on 8. I'm almost certainly going to want decimal anyway. Try it both ways on your calculator to make sure that you're getting it right. Type this in, ask for an approximate value, and then try typing that in and see if you get the same answer. And yeah, I'm not sure how to do on yours. You can look, but I'm guessing it doesn't have
For what?
the distribution. Go to where you normally get your...
I got the norm and then NPD. But that's not.
It's still going to be normal, and you've got a binomial. See, that's very common. You've also got these funny ones, T's and Chi's and things.
What about Poisson?
Poisson. Yes, actually Poisson is quite similar to this. Oh,
There's Geo as well.
you might be able to use a Poisson for this, but look, it's not difficult.
I can, I think. Look, it has the lambda as well.
And to give you the right number,
I'll have to try.
check that. According to the textbook, you should get... Do I need to show you how to do it?
Yeah, I got the same answer for both.
Yep, was it 0.313?
No, I got 0.3. Oh yeah, I did get 0.313.
Yeah, there you go. There you go. If you work it out. Yeah,
So you can just chuck in your calculator.
you forgot the negative sign, negative 1/8. Yeah, that's correct. Make sense?
Indeed.
Less than 3 minutes. Which part of the curve am I looking for? 0 to 3. I don't need to go past 0 because there's no area to the left. What if I asked you, calculate the probability that the next bus won't arrive for at least 15 minutes. Which means I want this area to the right hand side.
Does this like graph reset anytime the bus comes? Is that what it is?
Yes.
Yeah.
Yes. Maybe I should say the word you're looking for rather than reset is independent. Each event is independent.
Yeah.
Each event is independent of whatever happened before. Yeah. Probability that it's more than 15 minutes is going to be the integral from 15 to infinity. Yes, you can type that on your calculator.
You can put infinity on your calculator.
You can. And if you can't, you can always just go 99999. Because it'll be pretty darn close to zero.
That's insane.
Approximately.
Yeah, same.
There's another way around that too, Ryan. This is also, if you prefer, 1 minus the integral from 0 to 15.
Okay.
So if you can't work out how to get it on the calculator, you can try, like if the calculator's just giving you zeros in funny places, try this way. It's the whole area 1 minus the left-hand side. And of course we could ask you what's the probability that the next bus arrives between 2 minutes and 4 minutes? And you just go 2 to 4. It's just an area. Make sense?
Mm-hmm.
That's most of what we need. The syllabus also talks about quantiles. Probabilities and quantiles. Oh, now I'll mention particularly for rain. Standard deviation is also 1 over lambda, as well as the mean.
So the standard deviation is the same as the mean?
Yes.
Okay.
Which might matter if they ask you a question involving samples. I'm going to ask 5 people or 5 whatever. That's something you'll do in Unit 4. Some of my hard questions do it, you won't be able to answer those questions.
Yeah.
But if they ask for a sample, you're going to go 1 over lambda as the standard deviation divided by root n.
Are you going to ask me that?
Possibly, but what's more important is the external exam could well ask you, because it's assumed knowledge.
Yeah.
Quantiles. What's a quantile? So, let's look back at this curve. Remember, it's 0 on the left, goes up and then goes down like this. So, quantiles, how do I say this? X coordinates are scores in the language of statistics. X coordinates are scores. Y coordinates are frequencies or probabilities of a particular value, but the area really represents the probability that we're looking for. But a quantile represents some fraction, some quantity of that area. So you will have heard of quartiles before, a quarter, a half, 3/4. You'll also know about the median, which is the same as the second quartile. So a quantile could, for example, be the first 10%, it's actually not there, it's here, 0.1. The first 10% of those probabilities. Or the next 30%. How long do I have to wait for there to be a 30% chance that the bus has turned up? I'm asking for a quantile.
3/8? No, Why am I lying? What's 30% of A?
What am I actually looking for? Let me answer the question. For example, if from the same example, let's make a D. How long would it take for there to be a 30% chance that the bus has turned up? Will turn up? I don't know what the correct grammar is there. Not sure.
It doesn't matter. It's fine.
Okay. So, what I'm asking for here is actually the 30%. So, somewhere here I've got 30% of the area. And I want to know how long. That's a score, that's a time. So I want the integral from 0 to the time I'm interested in. Let me call it B for bus. Of my function, 1/8 e to the negative 1/8 t dt. I want that probability to be 30%. You going to try and end solve?
Yeah.
It probably should work.
Yeah, I think it does.
You can solve this two ways. You can try using the graphics calculator, or you can do the integral yourself. Let me show you the integral first. So again, we're going negative e to the negative 1/8 t from 0 to b has to be 0.3. Which is negative e to the negative b on 8 plus e to the 0, which is 1. Whoops. Why am I putting equal signs here? Equals 0.3. Now you have to know your log rules. This is 1, right? So negative e to the negative b on 8 equals 0.3 minus 1. Which means e to the negative b on 8 is 0.7, which means negative b on 8 is log of 0.7, which means b is negative 8 log 0.7. So try two things for me. Type that in your calculator, and then try using a numerical solve on this and see if you get the same value.
Yeah, I did.
And it is?
2.853.
4.
2.85.
Frankly, 2.85 is fine. Minutes, right?
Yep.
If I needed minutes and seconds, I could turn it into minutes and seconds, but yeah. So that's using the quantile. I want the 0.3 quantile, the 30% quantile. In this case, we'd call that a 30th percentile. But I can put any probability I like in.
And it's the third decile?
Sorry?
Is it the third?
And the third decile, correct. We almost never call anything a decile, but yes, it is.
They're using the UCAT.
Oh, there you go.
Right,
There you go. In particular, a common question to ask is what's the median? So let's try. Calculate the median value for this random variable, which is to say the 50th percentile, which is to say integral from 0 to b of 1/8 e to the negative 1/8 t, t has to be a half. Solve that either way. Numerical solve, you've got a calculator, is fine. And tell me what you get.
5.55.
So that is, B is approximately what?
5.55.
5.55 minutes. You all got that number? Okay. Notice, for an exponential random variable, the median, let me just write median, the median is always less than the mean. The median is always less than the mean because the distribution is skewed. The mean is always made larger by a small number of very large values. So the median is actually less than the mean.